Friends, you all showed dedication in part 2. Truly thank you. Protection logic, carrier frequency behavior, harmonics impact and real field case studies. अंडरस्टैंडिंग के बाद अब आप VSD की रियल दुनिया के काफी करीब आ चुके हैं और जैसे पार्ट 2 के एंड में हमने प्रॉमिस किया था, पार्ट 3 से हम और डीप डाइव करेंगे उन टॉपिक्स में जहां मैक्सिमम टेक्नीशियंस, इंटर्न्स और इवन एक्सपीरियंस्ड इंजीनियर्स गलती करते हैं। आज का पार्ट 3 पूरा फोकस करेगा पैरामीटर ट्यूनिंग, एक्सेलरेशन प्रोफाइल्स, थर्मल बिहेवियर, करंट लिमिट लॉजिक और उन हिडन सेटिंग्स पर जो VSD को स्मार्ट बनाती हैं बट सही सेट ना हो तो सिस्टम को रिस्क में डाल देती हैं। सो दोस्तों, सीट बेल्ट टाइट कर लो क्योंकि पार्ट 3 से हम VSD के रियल ब्रेन को डिकोड करने वाले हैं। वेलकम बैक टू Electriverse, where every spark tells a story. This series will only become powerful when you follow each part in sequence. Part 1 laid your foundation. Part 2 explained system behavior. And Part 3 will take you one level higher, from understanding to real control. From here, you won't be a technician, you will become a drive specialist. Most people think that the main function of VSD is speed control. But the truth is, VSD's real power lies in protection. Any soft starter or mechanical gear can handle speed, but uncontrolled current, voltage surges, thermal overload, torque shocks, handling all these is only the work of VSD. Protection makes VSD smart, protection keeps the motor safe, and protection saves the plant from downtime. Overcurrent protection, log सिर्फ current limit cross समझते हैं, पर एक्चुअल सिस्टम में ओवरकरंट के 3 रियल सोर्सेज होते हैं। नंबर 1, मैकेनिकल ओवरलोड। पंप जैम हो, वाल्व बैंड हो, कन्वेयर में मटेरियल जैम हो जाए, मोटर को ज्यादा टोर्क चाहिए होता है, टोर्क की डिमांड बढ़ती है, करंट स्पाइक होता है। नंबर 2, इलेक्ट्रिकल प्रॉब्लम, मोटर वाइंडिंग में शॉर्टेड टर्न्स, फेज इंबैलेंस, लूज टर्मिनल्स, वाटर इंग्रेस, इलेक्ट्रिकल वीकनेस, करंट एबनॉर्मल होता है। नंबर 3, एक्सेलरेशन, टू फास्ट। अगर आपने एक्सेलरेशन टाइम बहुत कम सेट किया तो मोटर रिक्वायर्ड टोर्क इंस्टेंटली मांग लेगी। ये ड्राइव के करंट लिमिट को क्रॉस करा देता है। ये 3 रूट कॉजेस समझने से आप ओवर करंट ट्रिप्स को एक्यूरेटली डायग्नोज कर सकते हो। एंड नाउ एन इंपॉर्टेंट डिफरेंस, इन VSD देयर आर 2 सेपरेट सेटिंग्स, करंट लिमिट, ओवर करंट ट्रिप। Current limit equals soft boundary, restricts the drive. Current. Overcurrent trip equals hard boundary, shuts down the drive as soon as the limit is crossed. People get confused during interviews. Engineers make mistakes in the real plant. Therefore, this concept should be crystal clear. You must have heard many times, DC bus overvoltage, drive trip. But understanding the real behavior is important. When you slow down the motor due to the inertia of the motor load, it becomes a generator and feeds energy back into the DC bus. If the load is heavy, checkmark, conveyor, checkmark, crusher, checkmark, blower, checkmark, centrifuge, then overvoltage trip is almost guaranteed. This is why in industries, ramp down time is set very carefully. Remember one golden rule: short deceleration equals sure overvoltage. To stop the motor, its stored energy must dissipate somewhere. If the ramp down is aggressive, the DC bus voltage will overshoot and the drive will trip. Therefore, in heavy loads, never set a short ramp down time. The function of a braking resistor seems simple, burning off extra energy. But one point people miss: the braking resistor only works when the VSD's internal braking chopper is active. That is, just installing a resistor is not enough. The chopper configuration must be correct. Undervoltage trips are considered a nuisance by people. But undervoltage is actually a guardian. If the upstream supply is weak, cables are loose, or the transformer is heavily loaded, then the internal electronics of the VSD come under stress. Undervoltage trip protects the drive from component damage. Thermal protection is the brain of the VSD. The drive continuously calculates how much heat the motor and its IGBT are operating at. The I2T model predicts whether the heat will reach an unsafe level or not. If the prediction shows unsafe, the drive will trip despite being within the current limit. This feature prevents overheating accidents. Acceleration time seems like a small parameter, but its effect is very significant. Current surge, torque jerk, motor heating, bearing stress, mechanical shock, load instability. If acceleration is set too fast, then overcurrent plus vibration plus jerk trip becomes common. S-curve acceleration is an advanced feature which industries prefer a lot. It makes both start and stop smooth. Benefits: no jerks, no shock loads, no sudden torque jump, pump surges, reduce conveyor damage avoided. Where flow stability, smooth handling, or mechanical safety is important, S-curve is the best choice. The drive's performance directly depends on the nameplate data. If you make a mistake in rated current, rated voltage, rated frequency, or power factor, all protection logic will behave incorrectly. This is a small mistake, but the result can be very dangerous. Carrier frequency log सिर्फ मोटर साउंड से रिलेट करते हैं, पर रियल लाइफ बिहेवियर कुछ और ही है. लो कैरियर, मोटर हमिंग बट ड्राइव कूल हाई कैरियर. मोटर साइलेंट बट ड्राइव हॉट. यानी अगर आप साइलेंस चाहते हो तो ड्राइव कूलिंग सिस्टम स्ट्रॉन्ग होना मस्ट है. Long cable length distorts the output of VSD. Voltage reflections occur, dV/d, T spikes happen, and motor insulation stress increases. Therefore, in long cable applications, output reactor sine wave filter, dV/d, T filter, are industry standards. There's a golden flow of commissioning. Step 1, parameter verify. Step 2, rotation check. Step 3, no load, run. Step 4, slow ramp-up test. Step 5, observe, DC bus. Step 6, gradual load test. Step 7, protection log review. If you follow this sequence, then the VSD will operate reliably in the long term. Friends, this was part 3 of the VSD series. You can see that VSD is not just hardware, it is an intelligent protection system. Part 4 will be even more exciting, where we will discuss DV/DT EMI and RFI shielding practices, earthing mistakes, cable selection, field failures, OEM tuning secrets. If you found the video valuable, please like, comment, share, and subscribe to Electriverse so that this high-quality technical content takes your career to the next level. Thank you for watching Electriverse, where every spark tells a story. Stay charged, stay safe, stay happy.